All right, so in this question, we're trying to find possible coordinates of point B. Given the coordinates points A is 2, -3, and B is x, 3x minus 9, find the distance of A and the distance AB, square root of 40, find two possible coordinates of point B. So how we want to look at this problem is we know the distance between 2 points of space is given by the Pythagorean theorem, regardless of where they are. We know that to be true. You can think of it a little bit like this triangle here. If we have point A here, point B here, doesn't actually matter if point B were down here, it would still make this triangle. It just might be flipped a little differently. But if we have these 2 points, the distance between them, C, is given by the Pythagorean theorem. A squared plus B squared equals C squared, which is the length of the leg squared, the length of the leg squared, plus the length of the other leg squared equals the hypotenuse, the length of the hypotenuse squared. Now this is also known as the distance formula. If you look at this distance formula, this is the Pythagorean theorem. It's just rearranged a little bit so we can just plug the points in. So what they've done here is you square root both sides, so that square goes away. You square root this side, and we know that A, if you'll look at that, that's going to be the length of A is the x-coordinate of our second point minus the x-coordinate of our first point. The length of B is the y-coordinate of our second point minus the y-coordinate of our first point. So that's where this comes from. This is just the lengths of these legs of this triangle. That will give us the distance between them. Now here in the problem, we know that the distance between them, AB, is the square root of 40. So I have that written out here. This is just all these values plugged into the distance formula. The square root of 40, the distance between them, equals the square root of, we have the x-coordinate of our second point, B, which is x, minus the x-coordinate of our second point, our first point, A, which is 2, squared, plus we have the y-coordinate of our second point, which you'll notice is 3x minus 9, minus the y-coordinate of our first point, which is -3. That's squared. Now, if you take this formula and you simplify it, what I've done is I've simplified that, and I got 40 equals 3x minus 6 squared plus x minus 2 squared, that I just square rooted both sides. Really, I guess I've rearranged that, but it doesn't matter what order you do that addition in. You have x minus 2 and 3x minus 9 minus -3. That's just adding 3. So I get 3x minus 6. Now from here, you can go about different ways of solving for x. You could factor this. You could try to factor it. You could FOIL these, multiply these out, and you could try to solve for x algebraically that way. You could also take these and you could graph these. You could say y equals 40, and then y equals this, 3x minus 6 squared plus x minus 2 squared. And you could find the intersection point between them, and that would give you the value of x. No matter how you do it, once you have the value of x, you can just plug that back in here, and you can get your y value. Now, obviously, there's more than one solution to this equation here. That's why it's asking for two possible coordinates of B, because there's more than one way to solve this. There's more than one number that makes this equation true. If I go over to my second board here, what I've done is I've taken this equation from the previous board and I plugged it into Wolfram Alpha, and I asked it to solve it. And it gave me the results of 0 and 4. Now you'll notice here's the example of the graph here. They've simplified this part of the equation to just be 10 times x minus 2 squared, but then you have your 40, and these are the intersection points, 0 and 4. And that is how you solve this problem.